Hello, this is Professor Salahat, and in this video here, we try to work on homework problems from chapter 5. I'm sorry, from chapter 6 and homework 5. Since we skipped one of the chapters, the order in here is not the same. So chapter 6, homework 5. And we'll try to do maybe a third of the homework, and we'll do another video and a third video to make sure that all the homework problems are covered. In this problem in here, they give us C equal to 94% or 0.94. And in here, they are asking us to find the Z critical. And we mentioned in previous videos that to find the Z critical, we can use stat crunch. And to use stat crunch, we need to follow those steps. Stat, calculators, normal. Then after that, we continue in there and complete the steps. And I'm going to show you how we do that in here. So I'm going to try to open the stat crunch in here. I'll just put it in here. I'm going to try to make this large enough for us to see. I'm going to go to the stat key here and drop down to calculator. Then it's supposed to open to the right, but now it's opening to the left because of the resizing of the window. We're going to go down all the way to normal. Click on normal. Then after that, you're going to see this window, and that's what I meant by the arrow here. You need to fill this information in. The only thing you really need to do is you need to make sure that you have to press between. Because always when we talk about confidence intervals, the interval is always that it is between. So in this case, make sure you press the between key. Then you fill in the last box here, you fill in the confidence level, which is, in this problem, it is 0.94. So I'm going to put in 0.94. It is already there, so 0.94. And when I put the 0.94 and hit the compute, and that's going to give me this value here that I highlighted there. That is the Z critical. So the Z critical in this case is equal to 1.8808. Notice that I don't need all of that, so let me just put this down. Go back to my problem. The Z critical is needed to 2 decimal places. So if it's to 2 decimal places, just type in there 1.88. So we're going to put 1.88 in that location and hit enter, and it tells us the correct answer. Now, let's go to the next question. In the next question in here, they are talking about, or they gave us 2 values in number 2. They gave us in number 2 that sample mean, which is equal to 3.8, and they gave us the population mean, which is, in this case, is 4.48. We know that the sampling error is always equal to the sample mean minus population mean. In this case, the sampling error is going to be 3.8 minus 4.48. And we have to be very careful in here. We don't put 4.48 first. We have to put the 3.8 minus 4.48. And I'm using a calculator on the side in here. And the answer in my case in here, the answer in my case here is going to be, and again, let me emphasize this, it's a native, and it's going to be 0.68. Notice that the native here is very important. The native tells us that our sample delivered a mean lower than the true mean. So that is the reason why we have the native sign. So go back in here and put native. Just use the native on your keyboard and 0.68, and that, when you check the answer, that should give you the correct answer. Now, for number 3, if we look at number 3 carefully, we are given in number 3 C, which is equal to 0.90. We are given sigma, which is equal to 3.2. We're given n equal to 49. And in this problem here, they want us to calculate the error or the margin of error. We know the margin of error by definition is equal to, remember, because sigma is given, and notice that because sigma is given, always we use Z. So it's going to be Z critical times the sigma over radical of n. So we know what the sigma is and we know what the n is. The only thing missing in this case is to know what the Z critical. Now to find the Z critical, we use the same method as we did in number 1 or question 1. We're going to go to stat. We're going to go to calculators. And we're going to go to normal. And since we know what the C is, we're going to fill in the C and we don't forget the between. And when we plug in the C in the last box, this should give us the answer we're looking for. So let me just redo this in here with StatCrunch, stat, calculators, go to the right to normal, and don't forget the between. And since C is, and again, circling the C, since C is 0.9, you're going to go in there and just put 0.90, and that should give you the Z critical. So the Z critical that we got, so let me just write this in here. And the error is going to be the Z critical. The Z critical, by looking in here, we're going to find it's 1.6449. Again, it is in here. That's Z critical. Under the curve in here, it is Z critical. Now times the sigma, in this case, sigma is 3.2, divided by radical of n, which is 49. Again, we plugged in the n here. We plugged in the sigma here. And we find the Z from before. So if I go ahead and use my calculator, let me move my calculator in here and use it. I'm going to turn my calculator on and put 1.6449 times 3.2, because this is really a multiplication here, divided by, because this line in here is a division. So we're going to divide by, and we know that the square root of 49 is 7. We just put 7. Or if you want to put radical 49, it will work. When you hit compute, let me get the answer in here. The answer for the error is going to be 0.751954. And we go on. In this case, we don't need the whole number because in the problem here, let me minimize those two windows. In here, they say round to 3 decimal places. So it's going to be 0.75. And notice that because the third place is a 1 and past that is a 9, we're going to round this one up. So this is going to be a 2. So it's going to be 0.752. When you put 0.752 and check the answer, it should be okay. Now, let's move on to number 4. In number 4, they gave us C, which is equal to 0.90. They give us X bar, which is equal to 6.4. They give us sigma, which is 6, or sigma is 0.5. They gave us N, which is equal to 42. And the question in here to find the confidence interval. So to find the confidence interval, CI is confidence interval, we can directly go to StatCrunch without doing any math, and we can go follow those steps. And the steps are stat. Then we're going to remember, because sigma is given, let me emphasize this, because sigma is given, we're going to use Z stats. And after that, we're going to go to one sample. And then we're going to go to with summary. And because we say with summary, because this is in statistics, it's called the summary. So we are given a summary, so we're going to use with summary. So with summary, then after that, you're going to get a new window and you're going to fill the data that you have. You're going to fill this summary as given. So let me just show you how we do that. Here is, let me close this. We're following those steps. Stat. Then we're going to go down to Z stat. We're going to go to one sample, and we're going to go to one sample with summary. And when we click on that, in the sample mean, notice that the sample mean is the same as X bar. So X bar is the sample mean always. So X bar in this case is 6.4. And the standard deviation, which is sigma, 0.5. And the sample size is 42 in this problem. And then they want us to find confidence interval. So the confidence interval is this here. Let's go back to the StatCrunch. Here's the circle there. Check that in. And the confidence interval, to be able to do that, you need to find or you need to have a confidence level. In this case, it is 90%. So just put the 0.90 in there and hit compute, and that will give you the interval. So the interval we got, let me write it down in here. It will help me. The interval we get is a left side is 6.27. Let me go 4 places, 3, 1, and 6.5269. Now let's go back to the problem and see exactly what they want. They want to 2 decimal places. So let me put this down. We don't want 4 places. We want only 2 places. So we're going to put in there 6.27. And in the second place, we're going to put 6.53. 2 places. And we check the answer. Should give us the correct answer. Now with number 5. In number 5, they ask us to find the n, or the sample size, because the question in here says find the minimum sample size n needed to estimate mu for the given values of C, sigma, and E. In this case, they gave us C equal to 95% or 0.95, sigma is equal to 8.2, and they give us the error equal to 2. Notice, and again, in one of the videos about how to find the sample size, I talked about this. To find the sample size, because again, sigma is given, we're going to go to stat, and we're going to go to z stats. This is when sigma makes a difference. If sigma is given, we're going to use z stat. Later on, if sigma is not given, we're going to use t stats. Then you're going to go to one sample, but you're not going to go to a summary. You're going to go to the width or sample size, and you're going to fill in the data in there, the data that you have in there. So let's see how we do that with StatCrunch. Let's close this, and let's go in here and try to fill in the data given. We're going to go to stat, and we're going to go down to ZStat, and we're going to go to one sample. But notice that in here, I don't go to summary anymore. I'm going to go to the width or sample size, because the question is asking what is the sample size. So I click in there, and I get this window. And then I try to fill in everything I know in here. So what do I know? I know the confidence level is 95%. Just leave it 0.95, because it's given in here, it's 95%. I know the standard deviation given in the problem is equal to 8.2, so we need to fill in 8.2. Now, this is one thing we need to pay attention to. What is the width? The width is not given here. What is given here is the error. The error is given. Notice that usually the interval looks like this. Here is the center, which we call it usually X bar. And this is the lower, and this is the upper. And the error is, this is an error, and this is an error. And always the width is the width of the interval from the far left to the far right. And in this case, always the width is going to be equal to 2 errors. So in this example, if the error is 2, the width is going to be 2 times 2, which is equal to 4. So that's the reason why we go to the width in here and we put 4. Then the last thing we need to know is the sample size n, and that is the question. So leave the last box in here empty and hit compute, and that is going to give you here is going to give you n equal to 65. So you need to survey at least 65. 66 is good, but anything less than 65 is a problem. So the question in here is asking what's the minimum. So you don't give 66, you give the minimum, which is 65. And we go back and put 65 in here, and we check the answer, and it will be okay. Now let's go to number 6. In number 6, they gave us already an interval. They told us in here, a biologist reports a confidence interval of 3.9 to 4.7. So this is what we know. We know that the lower limit is 3.9, the upper limit is 4.7. Okay? And in the question in here, they are asking us to do what? To estimate the margin of error. Now, before we go to the margin of error, we know that the middle of the interval here is the center is the same as the mean. So let's find the center or the mean. Now we all know that if you have two numbers, the center will be the average. So the mean is always x bar. So x bar is equal to the 3.9 plus the 4.7 divided by 2. So if you pull your calculator out and put 3.9 and you add 3.9 to 4.7, you're going to get a total of 0.6 and divide by 2, and that will give you 4.3. So you're going to get 4.3 for the center. Now we know that the distance from the center to the bottom is an error. So the question is saying, what is the error? So the error in this case will be the distance from 3.9 to 4.3, or 4.3 is 3.9. And if you do the math in here, is going to be equal to 0.4. Notice that if you flip the numbers, it will be a negative, but the error is never negative. Now we talk about the margin of error. The margin of error is never negative, so you're going to get 0.4. So we just go in here and just put the error to be 0.4 and double check, and it's good. Now the second thing is asked for, what is the sample mean? Notice that the sample mean already, we found the sample mean before we found the error. This is the sample mean. This is the sample mean. So the sample mean is the center always. So it's going to be 4.3. So you just put 4.3 there and you check the answer, and it's a good thing. Now, let me redo this problem. Okay. I did this problem for somebody else, so let me redo this one here. Just ignore the answers in the problem. And that is number, oops, let me make this smaller. Yes. This is number 7. In number 7, it is asking us in 3 parts of the problem. Actually, in number 7, let's read in here. And in this case, they ask us to find the confidence interval, or confidence interval, yes, for 2 confidence levels, 90% and 95%. So we're going to do them separate. But what they gave us, let's read in here, and I'm going to highlight the important part in here. It says, if you read this carefully, it says a random sample of 55. In other words, n is equal to 55, or the sample size of 55 home theater systems has a mean price. The mean price is $134. Notice that the mean price of the 55, that's the reason why we call that X bar. Assume, and this is very, very, very important. They are asking us to assume something. What they are asking us to assume? They are asking us to assume that the population standard deviation. In other words, they are telling us to assume sigma is 17.5. Okay, they didn't tell us the sample standard deviation is, but the population standard deviation is. So this is very important. Automatically, I know because sigma is given, I know I have to use a z. Okay, so the question is here, they want us to find or construct a confidence interval for 90% in part A. But to construct a confidence interval, as we did with a previous number, I think number 3 or something like that. Yeah, in number 4 actually. In number 4, it's the same steps as in 4. Now, if somebody tells you to construct a confidence interval, you're going to follow those steps. You're going to follow stat, z stats, one sample with summary, and you're going to fill the data. So let me go in and try to do this in here. Okay, I'm going to follow the steps. Here, I'm going to go to stat, z stat, and we know why it's z stat, because sigma is given, and it's one sample, and with summary. And in here, we need to fill in the sample mean. Be careful, the sample mean is 134, that's X bar. He asks us for the standard deviation, which is 17.5, which is a population standard deviation here. Sample size, which is 55 people, and we're going to go down to the confidence level. And in part A, they tell us to use 90%. So we're going to put in here 90%. And if we put 90% and hit compute, for part A, the interval is going to be equal to 130 point. Let's go to 2 places. One, in case they want more, we can come back and do it. 1, 2, and this is 137.88. So if I go back in here, and see exactly what they want. Yeah, they want it. So actually, I put in here 130.11, and it should be for the previous student, and it should be, let me go back in here. It should be 130.12. Now, actually, because the program here is lenient a little bit, so what, if you put 11 or 12, it's not going to be a problem. But the right thing to do is to put 12 for the lower limit. And the upper limit is 137.88, so it is 137.8 as you see in here. Now, what if they change their mind and they say, listen, we want you to do part B, which is we want you to change the C to 95%. Look how easy with StatCrunch you can do that. Let me go back to StatCrunch. With StatCrunch, when you get this window, you don't have to really go back and put the numbers in again. Just go to Options and go to Edit. It is the same numbers there, 134, 17.5, 55. What you need to do is just go down to the confidence level and change it to 95% and hit Compute, and that will give you a new interval, and the new interval is going to be 129.38 and 138.62. Again, I'm looking here at the lower and the upper limits. So I needed only two places, and that's the reason why we have 129.38 and 138.63. And in the problem we did here, it gives me 6.2. It's not 6.3. Okay. So what is the third question? The third question is saying, give an interpretation of your answer. Choose the correct answer below. And in here, there are three options. With 90% confidence, can be said that the population mean price lies in the interval. With 95% confidence, it can be said that the population mean price lies in the second interval. The 95% confidence interval is narrower than the 90%. Now, let's talk about narrower for a minute. Let me draw a picture. Notice that with 90%, okay, the interval is going to be narrower than 95%. How come? Because if you want to include 90, you need less space than if you need 95. So we now know that 90% is narrower. So the first question in here says the 95% confidence interval is narrower, and that is not true. The 95% is wider, so it's not A. What about B? With 90% confidence, it can be said that the population mean price lies in the first interval. With 95%, it can be said that the population mean price lies in the second interval. The 95% confidence interval is wider. Okay? That is true for the confidence interval is wider. Let's read part C. With 90% confidence interval, it can be said that the sample mean price lies in the first interval. With 95% confidence lies in the second interval. Everything is lovely, but there is a problem. And it says in here, the confidence, look at this one here. Here it says the 95% is wider than the 90, and here it says the 95% is wider than the 90. Both B and C, they talk about 95 wider than 90, which is correct. But what is the difference between B and C? The difference in here we're talking about the population mean. Here we're talking about the sample mean. Notice that the confidence interval is designed to capture the population mean, not the sample mean, because the sample mean is just a number. We don't need an interval for a sample mean, but we need an interval for the population mean to capture that. So the correct answer will be for the population mean and not the sample mean, so it's going to be part B. And if you check part B, it should give you the correct answer. So you have to be careful with that. Now, I'm going to stop here. I'm going to add more recordings later on. I'll finish this homework with other recordings, just to make sure that I don't make the recording very long for you to watch.